Welcome, everybody. It's my pleasure to be here and present to you the activities we have at Cranfield University. Cranfield University is a postgraduate education only, so we offer degrees in master's, PhD, master's thought component, and master's by research. And I am the course director for the MSc in Computational and Software Techniques and Engineering. So a little bit of geography. That was never my strongest point when I was at school, maybe because I liked computer science too much. So where is Cranfield? Cranfield is about 40 to 50 minutes north of London by train. We are close to Bedford and Milton Keynes. Bedford is a more traditional city. Milton Keynes is a more modern one. And we are unique in a way that we are the only university in Europe, as far as we know, that has its own airport. So I'm showing here an aerial picture of our campus, and you can see the airport, which is part of our teaching activities as well. So a little bit of an introduction to what is Cranfield. As I said, it's a postgraduate education only institution. So that gives us the advantage of, first of all, bringing research and industrial contacts, our contacts directly into our master's teaching and to our master's students. So that gives exposure to the students in research and industrially relevant activities and knowledge. Being postgraduate education only, we do not have the masses of undergraduate students. So essentially that gives us the privilege to have a 1:8 faculty to student staff. This is actually one of the best staff to student ratios you can find for UK universities. Our department is a part of the School of Engineering. I know earlier you heard about rankings, so not having undergraduate education in Cranfield does not always put us in the league tables where undergraduate universities are ranked. However, if you would like to know more about the quality of Cranfield, you can look at the top QS World University rankings, which are world renowned for undergraduate and postgraduate education. And in there, we are top students. We are in the School of Engineering, and in the most recent 2022 rankings, we got top 27 in the world. And actually, we are number 5 in the UK. So we boast, we're happy, we're one of the best postgraduate universities. With regards to our research, which is very tightly coupled with our teaching activities, the most recent rankings were actually announced earlier this week, which was the REF, that's the Research Evaluation Framework of 2021. That's when that national ranking was done, and the results were announced earlier this week. So again, we take pride in terms of our research power. We are 7th in the UK. So one of the best universities in the UK where it comes to research power. We are 6-time winner of the prestigious Queen's Anniversary Prize. So our research is having exposure and is being appreciated on a national and international level. 88% of our research is classed as world leading, and we bring that into our MSCs. I would like to give you a feeling of what you can do during your MSCs. So I got the current statistics from the current academic year, that is academic year 2021-22. At this point of time, our students are undertaking their thesis project. So of the 51 master's students who take their project this year in computational science, 31 of them already have paid internship positions in industrial collaborators. So 31 out of the 51 students have chosen to undertake their thesis with one of our partners in the partners' facilities, so in the industry, getting paid with the prospects of long-term employability. I think that ratio, 60%, is giving evidence and an indication of the knowledge you get during the MSc, how much it is appreciated when it comes for you to get a job. So before you even finish your MSc, 60% of the students are having paid positions. We are a postgraduate education only, which means that we attract many international students. We take pride in our global student forum. I personally collect these statistics, so you can see here countries where our most recent MSc students have come from. And every year I ask the students on their first day, if you don't see your country here, raise your hand and let me know, because I'm really keen to expand our global community, our global family. Again, a little bit of an overview of what type of facilities you will get to see and have access to when you come study at Cranfield. So as an MSc, and as a center, as a department, we have access to the Aerospace Integration Research Center. This is a big national investment. It is in Cranfield, and our center is doing work in terms of virtual reality and flight simulators. So if you study with us, one of the projects you could be working on is how can we build more robust, faster software using CPUs or GPUs that will enable our partners, such as Airbus, to have better and more realistic flight simulators. DARTEC is a very new facility. It actually we had the opening during the pandemic. That is the Digital Aviation Research and Technology Center. As you can see, again, this is a very big investment involving national funding from the UK, that's the higher education healthcare funding, of course from Cranfields, but as well as Saab, Boeing, Thales, Raytheon, big industry names. So the work that you as a student, if you choose to do your master's or PhD in Cranfield, you can be involved in the airports of the future, the airlines of the future. And we do a lot of work there in terms of machine learning, deep learning, and artificial intelligence. So the aviation industry has a lot of data, has a lot of images. Our students are working on the automated understanding, the data analytics, the machine learning. How can we get more out of these data sets and improve the airports of the future? So the MSc, first of all, it is accredited by IET, that is the Institution of Engineering and Technology. So this is a national body, and the MSc is accredited, which means that when you graduate from the MSc, you can automatically apply to become a chartered engineer. So your master's degree will take you one step further, because as a chartered engineer, having that title on your CV is giving you a lead when you apply for jobs later on. And that accreditation goes outside the UK, because the national bodies, they have agreements with each other. So you choose to move to a different country to work there, your degree will be recognized and your status will also be recognized. The MSc is cross-disciplinary, so we do not have a pure computer science course. Computer science has a very wide spectrum of applications. Within the MSc, we have 4 parallel streams, MSc options running. We have the computational engineering design. We have the computational intelligence for data analytics. We have the computer and machine vision. And we have the software engineering for technical computing. Each one of these specialization options will give you different skills, different strengths, all of them within a cross-disciplinary area, which is better in a way. When you look for a job, you have a wider spectrum of industries or job opportunities where you can apply your skills on. One common thing across all the specialization options of the MSc is high performance computing. You will have access to local high performance computing facilities. So that the photograph that I show here is from a cluster that we have local to the university for access only to MSc students. So you will get to use the state-of-the-art in computing for GPUs or CPUs, where you will get the skills on solving larger and more complex problems that are not necessarily solvable within a traditional computer, such as a laptop or a desktop or a server computer. And that facility you will have access during your studies. So what do your studies look like? The course structure, you start in October, and until February, you have the TOT component. So this is where you will have your classes essentially. Then March and April, very common in Cranfield, and we have it in our MSc, is the group project, where you will be working with other students from the different disciplines of the MSc in order to solve a challenging problem from the industry or the research community. And then between May and August, this is where you will be doing your individual research project, which you can choose to undertake within the university or with one of our industrial partners. So starting from the TOT component, there are some modules, classes that are common for everybody. Unique to us is the Management for Technology from the School of Management in Cranfield University, one of the best schools of management in the country, in Europe, in the world, where you will get knowledge about how you can manage large projects, how you can create your own company, how you can manage your own teams as you go up in the hierarchy. And then after the common modules, you will then get specialized classes, modules, within your specialization area. I do not want to bore you with the details for every class. You can see the names on the right-hand side of the slide. In short, in the computational engineering design option, you will learn the skills for pre-processing, processing, and post-processing simulations. The industry relies a lot on simulations. That's versus experiments, because that's the cheaper and faster way to test new ideas, new products. You will learn how to use these softwares, how to create the models, and then check if they should be trusted or not before they go into production. In the computational intelligence for data analytics, you will get more information about machine learning, AI, and high-performance computing, and apply this knowledge in a range of applications. In computer and machine vision, as the name suggests, there is a lot of data. There's a plethora of data around us, coming from sensors, coming from cameras. How can we automate the process of understanding what happens around us? You will learn how to develop your own algorithms. So building code is paramount during the MSc, as well as using some of state-of-the-art software that is there and is used by the industry. And then finally, the software engineering for technical computing, as the name suggests, you will build strong software engineering skills, not strictly within the context of how do I build software, but also how do I build software that solves problems, applications, and how do I work in these cross-disciplinary teams? So you get that exposure of how do I work. The whole MSc is steered towards what happens after. So for example, for all these classes that are modules that I have shown to you, you are not assessed by exams. You are assessed by reports. You are assessed by presentations. You have to write your own code. And then you couple that with group work as well. So some of the assessments are individual, some of the assessments are group, because we want you to build these transferable skills of how do I work with others? Because this is what people will expect from you when you graduate. I have some project examples here from previous years. So our students get to solve challenging problems, some of them at an international level. So that's an example from a couple of years ago where the students worked on an international grand challenge, which we had to make an understanding of social networks. So large data sets there to be processed on the fly. Environmental problems. And actually the student, Robert, the first author here, and Ben, the third author here, two students worked on the project of, we have an oil spill, and that oil spill travels in time. Can we intelligently build on the knowledge from satellites, from sensors, in order to figure out where the oil spill will find itself in 24 or 48 hours, and therefore use that. So this is actually used in a real search and rescue scenarios right now. And the students got academic publication out of this, recognized by great academics worldwide. This is an example of the group project that the students worked this year on, and that was how can we use machine learning and computer vision in order to automatically identify vortices. And this is what the vortex would look like. Okay, can we use our knowledge in order to identify that automatically? That's a very big problem worldwide. Formula One, for example, they are really keen on being able to identify vorticity when the Formula One cars are racing. And you see here the students presenting their work. They had oral presentations, they had poster presentations, and you can see here people from the industry. So we had people from Rolls-Royce attending the presentations, for example, and they talked to the students, and the students talked to the industry, and they took pride in presenting their group work. It's not only about the industry. The research component is important. So I have a few examples here where you can see our students publishing work out of their thesis together with their supervisors in world-renowned academic journals. This speaks volumes for the quality of the work the students can produce. Our MSc has an industrial advisory board that oversees what we teach and how we teach things. So I'm not going in the class to discuss what my teachers taught me 20, 30, 40 years ago. We go in the class and we teach the type of things that our industrial partners tell us they need, the skills they need. And then you can recognize some of these logos and you can recognize many of these names because these are the big players in the industry today, and they advise us about how our MSc should evolve. And our students, when they graduate, you can see here some of the companies where our graduates go work for. I have some information about some positions. I have hidden the names for privacy purposes, GDPR, but you can see company and position names. So these are positions you could have. These are things you could do once you graduate from our MSc. I have a few testimonials from students. You can see them on the website. they are just here to say that, you know, it's not Irene coming in today and tell you, oh, we do a great job. It's the students as well having that feeling when they graduate from us. Do I have a few minutes for a short video, or is the time up? Okay, I will play the video then.
Go ahead. Go ahead.
Thank you.
So the content of the group design project takes place over a whole day, and each group has the opportunity to present to their peer groups, to the academics, and to the industrial panel that are driving the problems and the projects.
The title of the group project was to integrate deep learning, machine learning, and artificial intelligence software tools into open phone simulations, which are related to CFD problems.
It is a variety of skills and knowledge we have brought together. The projects they have worked on are truly interdisciplinary. So we have brought in skills from computational fluid dynamics, skills from high-performance computing, software engineering, machine learning, and artificial intelligence. Of course, these are all the technical skills, and we do need to complement these with soft skills, time management, working in a group, all these skills that are really important in our everyday life.
Actually, I already have quite experience in software development. But one thing I was always working with the same type of team. So everyone is software engineers and everyone is from my same place kind of. But this group project, the beauty is like you are working with different people from different courses as well. So this helped me even if you don't know the problem, if you couldn't understand the problem, but work with different people from different courses, get their domain experience and their knowledge and apply those skills and complete the project. So, you know, this helps me whatever the challenges I have, even if I'm not sure of it, but this gives me confidence that I can do that.
Fortunately, I was accepted to do my internship here in the UK. It will include many of the things that I have learned here, and many of the things that we did as a team for the group project as well. So in that terms, the group project was really beneficial for me. All these simulations and the deep learning models are also going to be included in my thesis, which is going to be part of an industrial project of a specific company in the UK.
I'm doing an internship from tomorrow, actually. Yeah. I'm working for a startup. They're into machine learning and they want to optimize the automate the industry process. So I'm going to be a software engineer there.
Yeah, Cranfield is unique in the fact that students are working in parallel alongside leading industrial problems. It gives them that opportunity to work with industry and showcase to industry what they can do. And it gives them that advantage, as I said, in employment. But also it gives the students, and whatever universities can't offer, is a wholly postgraduate experience. The students at Cranfield are working on projects which are highly industrial related. They're highly technical problems, but they're also a real industrial problem. So having that demonstration that they can deliver in a short space of time is highly attractive to industry.
Okay, so that is the end of my presentation. Thank you very much, and I'll be happy to answer any questions later on in the breakout room. Thank you.